Uh, Today's presentation, it's going to be like an overview of the tools that we have available for reproducible data analysis. And this is a little bit of what I was trying to do with the evaporation calculation on for the course that I was taking with Arturo. Uh, this is going to be a little bit fast. And if this is like your first time seeing like this kind of tools, probably it's going to be like a lot of information, but I want you to have an overview of the tools and how you can use it in a reproducible workflow. And if you have interest after this meeting on getting the details of some of the tools and how you can learn about it, we can talk and probably do a workshop or something like that. Okay, so what we're going to see is like what is version control with Git, how to organize my workflow, especially using RStudio projects. We are going to use R and RStudio. And text and code, how we can take advantage of our markdown, what is code style, what is the dry principle, and a little bit of the DevOps concept and how we can use it. Why do we want to see everything of these tools? Well, you know that there is like a lack of reproducibility nowadays on science, and you can read a paper and you can read the methods, but if you want to recreate the steps that they follow to have some results, probably you are not going to find anything, not even the code or the data. So there is a crisis in reproducibility, and we can avoid this if we have these tools in our workflow. So what happens when we use, like, for example, R and other tools? Uh, we read the raw data. Let's say that we read the data from the Environet Open Data Platform. We import that data to our R project, and then we said, okay, I cannot wrangle this data in R, so I'm going to use Excel. And then on Excel, I'm going to press this button, and then I'm going to do click in this other button, and then I'm going to cut and paste data to one sheet to another. And at the end, we are going to lost our our steps, and we are going to have a mess in what we did. We we can even get to a point where there is no turning back to see, okay, how did I obtain this small data set, this summary of the data set? Where did I click? Where did I get this data? So if we lose those steps, we are lacking of reproducibility. So what we can do is to read the data, have a project in RStudio, recreate all the steps in R, and because as we advance in our exploration of the data, we are going to have different versions, and we can control those versions with Git, and also to have like a backup with GitHub. At the end, we can have a data product. It can be for communication, like an HTML file. It can be a shiny dashboard. It can be an API, an R package, or many things. But if we have this workflow, we can build many tools. Another idea over here is that try to think about using these tools because of your future self. Uh, Sometimes we are not pretty explicit in our code, and because we are thinking that, okay, yeah, I know the name of this data set, I know the name of the variables, and so on and so forth. But then we started another project, and we left that first project aside. And when we return to that first project, like 3 months later, probably you are going to be seeing the screen and saying like, what I was doing 3 months ago, I do not remember what was this step. So what we are going to use over here, it's some tools that can try to protect us from ourselves, and to try to have like a better organized workflow. Okay, so the first step, what is version control? What is Git? Git is a program where it is going to save all the historical points of your project, and you do that in order to avoid this. Probably you have experienced this. You have your final doc, and then you have a revision, and then you have like the final revision doc, and then you have another revision, and then you have like the last final doc, and so on and so forth, until you have many documents and you don't even know which one is the latest version. So with Git, we can have like a controlled version of all our files. And what I want to show you right here is um, some of the steps that you can use. So I'm going to use GitHub to create a repository. And on this repository, I'm going to save my files. Uh, so I created a Tropi-Dry organization on GitHub, and I'm going to create a repository. When we have data analysis projects, we have one repository per data analysis project. So let's say that I'm going to calculate evapotranspiration. So I'm going to have one repository for the calculation of evapotranspiration. In this case, we are going to create a repository where we can save a little bit of the examples from today. So we are going to call these tools, I don't know, for reproducible, well, analysis, let's say that. Analysis. And this is on GitHub. We are just creating one space on GitHub where we are going to save all our files. So the description of this repository is going to be the code and examples for the workshop. I'm going to make it public. I'm going to add a README file, and a README file is an extra file of your project just to communicate to other people what is this repo about. I'm going to add one special file that is called git ignore. And because Git is a program that is going to follow all the changes that we have in our files, sometimes I want that Git do not follow all my files in my project. For example, if I have passwords saved in a file over there, if I have tokens, or one of the files that I don't want that go through the control version are data files. So this git ignore file, it's going to be the one in which I'm going to indicate which file I don't want Git to consider. I'm going to use a template for R, and that's it. I'm going to create the repository. This is going to be the central repository. If we were working as a team, coding in this repository, this is going to be our central place to communicate and to have all the functional code. But in order to have functional code, we need to have like a secondary code where we are working and where we are testing and experimenting and developing. And that place is going to be our fork. So I'm going to have like a copy of this repository on GitHub under my profile. So I'm going to fork this. I'm going to say, okay, I want to fork this under my profile. So, and you will see over here that this is my fork because it's under my username and it has the same name of the main repository, while the other repository it's under Tropi-Dry. So now that I have this is all on GitHub. I still don't have this on my computer, and you will see that the repository have just the two files that we were talking about, the git ignore and the readme. So I want to clone this. I want to download this repository to my computer. So I'm going to open my terminal, and well, no, I can do it. I can do this from RStudio, and just wait a moment. And in RStudio, what I'm going to do is, okay, I'm going to use an RStudio project. I'm going to open a new project. Well, no, don't save. And I'm going to ask for a version control. This is Git, and I'm going to ask for the URL, and this is the URL. So in all the places of the internet that exist out there, I want my computer to find the info that is under this URL. I'm going to copy this one that is under this button. Okay, that I already copied. And that's it. I have the URL over here. I'm going to create project. This is a control version project with RStudio and R. So this is going to open. And as you can see, I have the README and I have the git ignore file, the same files that I got over here on GitHub. Plus, when I use RStudio, I created this R project file. And now I have my project on Git. I'm going to continue with some of the steps of Git while I show you other concepts of the reproducible tools. So we are going to put that aside, and I'm going to continue to explain you what are RStudio projects. You can have many folders on your computer, many directories, and you can organize your computer as whatever you want. For example, you can see these two people over here, and they are working in the same data analysis project. They are working together, they are collaborating in that project. But one person have the data analysis directory under user, under documents, under analysis, and then you find data analysis, while the other person have the directory user, then GitHub, and then data analysis. So both of them are working on the data analysis folder, but they organize their files differently in their computers. So let's say that they have the same data file that is called rawdata.csv, and they want to import that data file into their analysis project. One of them is going to write all the path to that file, like user, document, analysis, data, raw data, while the other person it's going to write like user, GitHub, data analysis, data, and raw data. But you will see that we have a pattern over here. We have the same directory, data analysis, then we can have the same folder in order to store the data, and we are going to call that data. And under that data folder, we are going to have our raw data file. So if we both have this uh, this folder, and we don't care about where you organize in your computer the data analysis folder, we can have a point in common between the persons that are collaborating in a project, and all the code is going to work for both of us. Because let's say that I'm working with Jose, and we both have data analysis project, and I'm going to import the raw data. I'm going to say it like read CSV, and I'm going to indicate that that CSV is going to be under data, and the file is called raw data. If I share my code with Jose if Jose have like the same structure, like data and raw data, that code is going to work on Jose's computer. So we are going to avoid crashes of code. And what I have said about avoiding crashes of code is that we don't want to use in our code set working directory. We don't want to use attach, or we don't want to use remove list ls. These are bad practices for reproducibility analysis. This is like a big red flag. This is like a little bit disorganized. And so if we want to avoid this, we can use RStudio projects. And there are other things that we can use with RStudio projects. We are going to have like a new R session. We can have like our profile, our data, our history, our environment, and some other files that are specifically designed to work inside data projects, inside directories. So they are not going to look further on your computer. They are going just to check under that specific directory of your data analysis project. And you can create a new directory, or if you already have one directory, you can create a project, or you can use a version control as the one that we were using in order to have the example on GitHub. What is the project structure that we want to use? This is the minimum that I use in my data analysis projects. I want a folder. Let's say that we have the data analysis directory. This is our project. And under that directory, I want to have a folder with my data. I want one folder with images that I can use, like logos, plots, for example. I want a folder where I can store R files, but specifically designed for functions. And outside those folders, I'm going to have my R markdown files. And this is the the main files of my directory, because here I have all my code to create my exploratory data analysis, for example, or my data analysis. But also I can have all the text where I can write my interpretation of the results. We are going to see in a moment what is an R markdown file. But this is the minimum structure that you want to have on your directory. There are other point of views on this. For example, John Blishak has this package that is workflow R, and his idea is that you should have like your directory of your project, and you will have like a git ignore the R profile. Then you are going to have like an analysis folder, and you're going to have like many more files. This adds a little bit more complexity to your project, but it is going to be really well documented. But if you at least have like these components, you are going to be fine. Okay, so let's go to our project, and let's say that, okay, I'm going to analyze some data. And which data I'm going to analyze? What I'm going to do is to copy and paste some data over here. And let me check. Now I have data over here. Well, in Spanglish, I have my data folder over here. And this is a folder that has like 3 CSV files. And I'm going to start analyzing these data observations. But I want to analyze this using another tool, that is R markdown. So we just have like the first step of our data structure. Let's say that if I'm going to save some images, I'm going to create a folder that says image, and I'm going to leave that over there, and that's it. I'm going to explain what is an R markdown file. So now that I have this, an R markdown file is a special kind of file because it is going to allow us to combine code with text. And the main idea of R Markdown comes from these two persons, John Gruber and Aaron Swartz. And R Markdown is not something special from R. It's just an idea that combines the previous idea of Markdown. And Markdown, it's this. When the internet was like starting to grow, you have to build a web page with HTML, and in order to have like text in this format, you will have to put these symbols over here. You will have to say, okay, this is a header of first order, an H1. Okay, that is going to look like that. And if you put these other symbols, you are going to have something like this. And then you can have like your paragraph, and then you have like some other attributes like italic, bold, and so on and so forth. So it was kind of messy to write all your plain HTML file. So these two people said, okay, we can try to make that uh, simple. And so let's create another syntax. And for example, if you want to put something in bold, you can have just to add uh, these symbols. If you want italic, just add these two symbols instead of aggregating all the paragraph, all the attributes, and so on and so forth. So with this syntax, you can have the same result as if you were working with HTML. So this is like a more simplified way to write HTML. And the idea behind our Markdown is to, okay, let's get this tool and try to create something where we can use our R language, our R code that works with Markdown. So now we can have text, and we can format our text, plus combine it with our R code and the results that we have with the with the with 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 the code. And by the way, I have a suggestion. If you don't know who is Aaron Swartz, you can go and check this documentary, The Internet's Own Boy. It's pretty cool, so I'm going to leave you that suggestion there. So my document in R Markdown. What am I going to do? How do I use this in R? I'm going to, this is the same project that we have been using. We have already our data over here, and I want to analyze that data. So I'm going to open an R Markdown file, and this is my data analysis, and that's it. So I have a template over here, and if I need this, it's going to transform all this text into an HTML file. So I'm going to save my analysis. I'm going to save the file. So you will see here, and this is the output. So you will see that you can have all the text formatted, and you can have the R code, and you can have the results. This is the template that you have with the R Markdown documents. So I'm going to erase all this because I don't need it. I want to create my own analysis, and you will see that you have this structure. This is a chunk. On the chunk, you are going to write your code. So I'm going to load some libraries that I'm probably going to use, like dplyr. I'm going to use, let's say, ggplot. And I'm going to use readr because I want to read those CSV files. So now I have these three libraries. I'm going to create a header. I'm going to put like import data. And here I can explain what I'm going to do. I'm going to read the three data files. And now we know that we have, I'm going to rename this to data. Okay, that is data. Okay, and I have three files. So I'm going to read the Setosa file. And what I'm going to do is read CSV file. And remember that I told you that I'm working in an R Studio project, so I don't have to put all my name. Let's check that file choose. Just wait a moment to show you what I mean. And this is tools for reproducible analysis. This is data, and I'm going to select this one. And this is all the directories involved in where my Setosa CSV file is. But if I send this to some of you, you are not going to have like home, you are not going to have the same name as me on the user, and probably you are going to organize this in a different way. But what we want to have is this structure from tools for reproducible analysis, and we want to have a data directory. So we can say, okay, I just want to read this Setosa data, and I'm going to set setosa.csv, and I have there. And now if I check the data, I have glimpse of Setosa, and I have my data loaded over here. And now I can start exploring this data file. And as you can see, you can combine like text with, I don't know, where is that symbol? Oh, there. You can combine like text with the code, and I'm going to show you like glimpse of my object that is called Setosa, and I'm going to need this. And now I have per data, I'm going to read three data files. I have my code over here, and then I have the result of glimpse of watching like the columns of that data set. We can create this like in a nice way, but I'm going to leave that over there for now. Other concept that I want to show is that we need to implement a code style. Why? Sometimes we combine styles, so we use like snake case instead of just lowercase, and we have like some names that it is not going to inform us about what is the object that we have in our hands. And we have some bad practices of calling our objects in R. So the best practices are, if we have a space, if we want to separate words, use an underscore. If you have a data object, don't call it data. Try to give it a name that goes related to what you are, what you have in that object. So for example, if I read some evapotranspiration data, I'm going to call that object evapotranspiration underscore data. Please don't use like the points, use an underscore, and don't use like just one letter. Try to write all the word. I know that this is going to cost you more typing, but at the end, if you write a project like this, and you create an object that is called pit p.013, and then you put aside that project, and then you come back 6 months later, when you read that p.013, probably you are going to ask yourself like, what is that object? What it was doing in that moment of my life? So try to be pretty explicit about what you are doing. Try to write everything. Try to write commentaries on your code. Try to write all the steps that you are doing. And there is other idea in code style. If you see code like this one, it is going to be pretty hard if you have an error. It is going to be pretty hard to detect if I am missing a comma, if I am missing a parenthesis of what is the error over there. So you can have like spaces between symbols. You can organize your code in a better way, and you can do it like this. This is the same code as the last slide, and you will see that to read this, it is easier than reading this chunk of code. And what you can do to read a little bit more about code style is to check the book, the art advanced R, and you will see that there is a chapter of code style, and that code style of R is based on the Google style uh, convention. You can have like different rules. If you have an organization, let's say that we are all going to work in a Tropi-Dry cool art project, so we can have our own conventions, but we have to communicate which conventions are we going to use so we can recreate all that code style when we merge all our collaborations, and we can read it faster. We can get the idea of the other person that was writing this code because I can read it easily. So try to implement these rules. Okay, so I'm going to get back over here. So let's say that we have like these three data sets, and uh, I want to just wait a moment. I want to read all these data files. So I have three data files, and let's say, okay, I need to read that file. I need to read versicolor, so I'm going to to do the same thing, like read CSV, and I have to indicate data, and I don't know why this doesn't autocomplete. There is there, and then I have to read the other data set, and I'm going to do read CSV, yeah, that one, and this is data, and I have, so now I have all my data sets. You can see it over here, glimpse of versicolor, and now I have this data set. So like uh, now that I have this, I repeated my code like 3 times. You will see that I have this pattern, read CSV from data, but then I have Setosa file, versicolor file, Virginica file. I am repeating myself over here, and that's a principle that we want to apply to our code. Do not repeat yourself principle. So this is another example that we are going to do. If I have this code, you will see that it's all the same, but the filter. This is code to create a plot, and the only difference between these chunks of code is that we have a filter per species. So we have one filter for Setosa, we have one filter for versicolor, and we have one filter per Virginica. But we are repeating all the other code. It is not necessary to do that. So if we don't want to repeat ourselves, and on this example, we are repeating ourselves pretty much, we can change this. We need to try to detect the pattern that repeats along the code and say, okay, what is the element that changes between those? And we can try to create a function. In R is uh, kind of easy, let's say, once you have the practice to create functions. And at the end, if you create functions for your data analysis because you have a need, you can save that function in your own R file. Then you can have your R directory with functions for your data analysis. And if you keep up doing that, at the end, you can probably have like your own package, like your own R package it doesn't have to be an official CRAN package, but it can be a package that it can be used internally in the organization. So it can save us time when we are doing analysis. So let's say that we are always reading eddy covariance data that always have the same names. And so if we want to import that data in R, we have to always go like read data, da, 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 da. We can have a function like read data from that folder, and that's it. And it is going to read all our data files in a loop, for example. But we have a function that save us time. And I'm going to show you like a small example about this. Let's say that I am reading these all three data files, and that I want to to avoid this. So I'm going to use another library that is called FS, and FS is for file system. So with FS, I have like, it was dir ls, and I'm going to say it over here that check the data folder. So if I do this, it is going to say, okay, Ronnie, you have under data one file that is called Setosa, you have another file that is called versicolor, and another file that is called Virginica. Okay, I have one step. And look what I have over here. This is what I'm using for this function. Now I want to do the read CSV for each of these files that are under the data directory. I want to loop over that action. So I'm going to use another library that is called pur. And let's say, okay, what is the pattern that I have? It's read CSV. Okay, so I'm going to use a pipe. You can read the pipe like after having this, do this other action. So I'm going to put in a chain several actions. So after having those objects, what we are going to do is to loop, and no, the of I don't remember. I'm going to loop over these objects, and I want you to read those objects with the function read CSV. Okay, that's it. I just want to name the function, and I'm going to say, okay, the ID of this, when you read that, it is going to be the file. So I'm going to close this. Just wait a moment to check if it is mapdfr. I can do it like this, I guess. Just let me check. Archivo, library pur. I have it over there. So there. Okay, now I have it. And you can see that I read all the data files in just one data file. If I check, let's check our environment. You will see that Setosa have 50 observations, Versicolor have 50 observations, and the same for Virginica. So if I read all those files that have the same columns in just one big data file, I will have in total 150 data observations. What I'm saying over here is that when you join all those data sets, keep a column that is called, and I'm doing this in Spanish. Oh, I don't know how you say file. That you have a column that saves the origin of those observations. So I'm going to put this in a project. I'm going to call this iris data. And this is reading all these three data files. Imagine that we have like one directory with 50 CSV files that we have to join in one data file. To read this, to write this 50 times, it's not the best way to do it. So you can do it with this loop. So now that I have this, I'm going to do glimpse of my object iris data, and now I have 150 observations, and I have like all the data sets. If you want to have an idea of this, like how we see it, we can do view and set like iris data. And we have, you will see over here, Setosa. It is the file that have the species Setosa, and over here we have data Virginica, and we have Virginica over here. So we have all those three data files in one data frame. Okay, so I'm exploring these files, and I'm going to create this just a plot, just to see what is happening over here. And I'm going to say, I'm going to change the chunk. I'm going to write over here like plots, and I'm going to open another. So I'm going to say iris data, and I'm going to say, okay, I want to filter my data by the column species. So I'm going to do another step over here. Remember that I told you to use code style and to not mix like uh, uppercase and lowercase. You will see that over here we have uppercase, lowercase, we have a point, we have uppercase. So you will say like, Ronnie, you are not applying your code style over there. And I can go through all the columns and rename the columns, but I'm a pretty lazy person. So I'm going to set, okay, library, I'm going to use this janitor package. And after I loop over those files, I'm going to say clean names. And look what I have right now. I'm going to say glimpse from my iris data, and I change the names. So petal width, I have it like this. So I'm now using like code style with just one simple function. So let's say over here that I'm going to filter a species. I want to use Setosa. And after this, I want to create a plot, and I'm going to specify the x-axis. The x-axis is going to be like whatever, like petal length, and the y-axis is going to be petal width, and that's it. And then I want to add like geom uh, points, and now I have my plot over here. So, but I want to make this a little bit pretty, so I can say like I want the points like bigger size, and I'm going to use another color. I'm going to use the same color that I was using over here, 7575 DV. It was DV, yeah. So now I change the points over there. Now I want to change the theme of the, and I'm going to put the, just do it like this. Now I have this graphic. Now I say, okay, cool. Now I have the plot that I want. Now I want to do this for all the species that I have in my data set. So let's check. I have unique, and this is iris data, and this is the variable species. And I have three species over there, and I say, okay, I want the same plot for the three species. I can copy and paste this like 3 times, and then change Setosa for this, for versicolor, and then I can change this for Virginica. And now I have like the three plots over here. And now I can knit this to see how it looks my HTML file. You will see that I have like all the code, the warnings of the code, and I have the three plots over here. Okay, that's okay, but let's think that I'm going to use this for other things. So I don't want to repeat myself, and I can't create a function to plot this stuff. So create I'm going to create a function that I'm going to call create plot. And this is going to be function, and this function is going to take 2 arguments, data, and because I want to filter per species, the function is going to take that argument. And so I'm going to call this I'm going to write this like that. So what my function is going to do, I want my function to do this. So I'm going to paste this over here. And now I have to match this. It is not going to be iris data. It is going to receive through the data argument what the user put as an input over there. Species is not going to be this one. It is going to be what the argument carries. So now I have my function, right? So we just said, okay, we have a function. I don't have to write 3 times all this. I can say it like create plot, and I'm going to say data is going to be iris data, and species name, it is going to be setosa. And I'm going to clean these plots just to check that this is going to work. And I run this, and now I have my plot. And I say, now I am not going to repeat myself, but if you check this, I will have to do the same for Virginica, and the other one was Setosa, Virginica, versicolor. And now I have different plots with one function. And we can iterate over this because even if we build a function, we are repeating ourselves. And we can loop through this and just use like the function per each of the species that it can find in the in the in the data set. So let's going to do that. I'm going to ask for the total species. So I'm going to ask for iris data, and I'm going to pipe this, and I'm going to select the column species, and then I'm going to say, okay, I want to distinct this, and then I want to pull this because I need a vector. So if we check this object, species total, now we have the names of those uh, of the species that are in my data set. Think that if the data set changes over time, if we are reading new data, this code can work because if we have 4 species, now this is going to detect 4 species. If we have 7 species in 2 months, this is going to detect 7 species. We are not going to write in our code this because this is an element that it can change over the time. So I'm going to map over the the, the data set that I have, but with this condition. We are going to take into account species total, and remember that species total have uh, our species over there. So this is going to be a function, and I'm going to do this. This is going to be a function inside a plot, and I'm going to use this plot. And what is this going to do? This is going to create a plot, and I'm going to erase this again. Yes, but it's not going to be by versicolor. It is going to be by the argument of the function. And if I do this, now I have an error. Let me check what I have over here. Datos, data, iris data, species name. Cannot see it like quite fast. Species name, data, iris data. Species total. Okay, that was the error. I was putting like plot over there, and now I have like the 3 plots over here. We can do a workshop on loops with map. I have 6 minutes, so everything that I have been working over here, it's to create like this file where we have our analysis, and we can write our text over there. So let's say that I'm going to change this, and this is the principal repository. Now change our mindset. We are going to explain how we can organize all this workflow, because you can tell me like, okay, Ronnie, you have not been using Git, and yes, I have not been using it. So with GitHub, you can organize your projects. You can create issues, and this can be tasks. Like, for example, create the first exploratory file. And this is going to be my first assignment. And I'm going to assign this to myself. And now I have one issue that is the number one. And what I'm going to do is that in the terminal, because this is a Git project, I'm going to create a new branch, Git checkout, and this is going to be related with the number of the issue, that is the number one, Git checkout. And now if I said, Git, please let me know what you find over there, and it says, okay, you have changes in all these files. I'm going to do something. I'm going to put the data in the repository, but just in order that you can follow all the examples. This is like a pretty small data set, so it is not going to affect. But if you put a big data set on the control version with Git, you're going to destroy your repository. Git is to check text files like an R file, a Python file, a text file, and so on, not for binary files uh, like CSV or Feather or things like that. So I'm going to add this. I'm going to say it like, Git, please take all these files into account. And I'm going to say, Git, now mark this point in the history of the project as something that we can turn back in the future. So I'm going to say this is like our first approach to the data. And I have that. And this is all in my computer. Now I need to send this to GitHub, because that is going to be like my backup or the way to communicate with all my team. So I'm going to say git push, and this is because it's the first time, origin, and sorry, this is origin without the T, origin T1. It's going to ask for my username, and then it's going to ask for my password. Let me just find this. Okay, and it's config credential punto. I'm going to save my passwords on Git. Git without the D. Git config credential. Okay, and what I'm going to do right now is that you are not going to see all the files here, but it says like Ronnie has some changes in that file. I'm going to compare and create a pull request. I'm going to ask someone to check my code. In this case, I can assign another person. This can be Jose, and but I'm going to do it myself, just an example. But it's better when that somebody review your code, because you can see all the files that have changes over here. So Jose can go through these files and say like, Ronnie, you have these errors. Ronnie, probably this is not going to work. You don't have code style over here. And so you can review my code before merging all that code into the main repository, because the main repository needs to have just functional code. All the development code needs to be in our branches. So I'm going to merge this. Let's say that Jose did this. And now you will see, if you go to this repository, let me open the chat so you can see it. So you can go to GitHub. You will see all the files that we have created over here. And let's say that now I'm going to close this issue. And if I continue to work on more issues and more assignments, and I can assign this specific task to the other people in my team, so we can divide our work in one repository. And this is the concept of DevOps in a pretty like big overview because there are many more details over there. But the DevOps concept is that we can plan ahead, we can create issues, we can create our tasks, and then we can create the code, we can verify the code, then we can create a data product like a package, and we can have versions and have releases and then configure and monitor all this workflow of code that we have been working on for 1 2 months and so on and so forth. And I have some book recommendations if you want to dig deeper on these topics that I have been talking about with R Markdown, Advanced R. And you can have like this one is pretty good if you want to learn Git. Is Happy Git with GitHub for the user. It is from Jenny Bryan and Jim Hester. And another book that I like a lot, it is not too technical, but it's like how to be a better programmer. What are like the habits that you need to have to be a better programmer? And with this pretty fast demonstration, I hope that you have at least an overview of the road, probably not the details and how to do it, but the diagram and the overview of how you can implement tools to have a reproducible workflow. And that's the hour. I don't know if you have questions or something to say about this.